Alright everyone, today I'll try to solve the Elite Code daily challenge, and I will try to solve it in such a way that as if I am in a real interview. So yeah, I haven't seen the problem yet, so let's get started. So let's see what is the problem of today. Okay, it is loading. Okay, the problem is find all duplicates in an array, and most probably I have solved it earlier. Yes, so find all duplicates in an array. Given an array nums of length n, where all integers nums are in the range 1 to n, and each integer appears once or twice. Return an array of all the integers that appears twice, and you must write an algorithm that runs in O of n time and uses only constant extra space. So let's think about it. Let's use Xcolor draw. Then let's copy this example and try to do a thing. Right, delete this all. Or maybe yep. Okay, so the nums is given as this, the output should be this, which is the repeating number. So here 2 is repeating, and if I try to somehow, if I try to minimize its shade, it's okay. So yeah, coming back to the problem, 2 is repeating, and what else, 3 is also repeating. So the answer is 2 and 3, and we have to find all the duplicates. So what should be the brute force solution if we think about it? Let's say for every integer, right, for every integer I run a loop and I try to find it in the whole array except the same index. So how would that run? So we need to use 2 for loops, wherein it would go from 0 to n, right? And here inside the loop there will be a condition. Inside the loop there will be another loop, which is for j equals to 0 and j less than n and j plus plus, and inside that too we will having a condition I not equals to j. That means you are not run the loop for the same index, and inside that if we are able to find the same element, that is if arr I equals to arr of j, that means there is a repetition. In that case we can save the number inside the data structure. Now what should be the data structure? We can take the data structure to be a set, an ordered set, right? Because the order is not mattering here, we can take a unordered set and store all the numbers which satisfy the condition, and later on using that set we can make a new vector using this syntax, vector int v. Let's say our set name is st, and then st dot begin, and we can do st dot end. So that should be our brute force solution, which is using 2 for loops, right? So the time complexity time complexity becomes O of n square. Okay, O of n square it becomes so here time complexity would be O of n square because we are using two loops, and also we are inserting in the unordered set, right? So that would take about O of into the complexity, right? Unordered set, unordered set C++ insertion time complexity is O of 1, right? It is constant, so that would be O of 1, so it boils down to O of 1 square only. And as for the space complexity, we are using a set which will be having all the unique keys that can appear in our vector, the input vector. So that can be if the size of the array is n and it is saying that they are of the range 1 to n, then there can only appear n keys. So I am assuming in the worst case we are having let's say O of, let's call it O of k, right? For the set it is taking O of k, that where k represents the unique keys, and as for the vector we will be having our only those which are duplicates, right? And what would be the duplicates? Okay, so n integers are there and k unique keys. In the worst case, how many repetitions can be there? Yeah, I mean for repetition also you are returning only unique values, right? So that would also be O of k. So that means our space complexity also becomes O of k. So this, that was about that was for the brute force solution. Now let's talk about the better solution. What could be the better solution for this? Find the problem. Each element uses constant extra space. Okay, here in the above approach we used extra space, so we should improve it. And also the time complexity was not linear, so that is also what we need to improve. Yeah, we can also do a thing like we can sort the array which take n log n, and by using let's say by traversing the array we can find the duplicates and store them in us and store them, right? So let's say I have I array which is sorted and it appears like this, right? It appears like this, right? And so the array appears like this, and we can just, whenever we find a condition wherein ARR of I is equal to ARR of I plus 1, then we can store that ARR I, and we do not need to use any set for that, because we can use a vector to store these keys that are repeating, and then we can skip these repeated numbers, right, using loop. Similarly, we will store this and we first store this, we'll store this, then skip rest of the repetitions, then we store this, then skip other repetitions, then store this. So in this way we end up having the complexity sorting plus traversing the array, right? So that would result in n log n plus traversing, that means O of n. And as for the space complexity, what would be the space complexity? The space complexity that will only be the numbers that are repeating, and how many numbers can repeat. At most that I don't know, that that would be O of R, and I am assuming that these are the keys that are repeating, right? Because at the end of the day we will be storing only keys, only the keys that are repeating, only the numbers that are repeating, right? And how many numbers can repeat? I am assuming it to be R, so I am saying it is O of R for the vector that we will be returning, right? Okay, now let's talk about the optimal solution, or better than the previous one. Now the thing is, we need to do in constant space. So we should not use any extra space. Here this was not extra space, it was actually space used to that is required, because we have to return a vector in the answer, right? So this is required for the vector itself, and then here the complexity, the time complexity is not linear, so this is what we need to improve, and that for that we have something called as cyclic sort. So this is a sorting algorithm, and the hint to apply is whenever you see a range of something like this or something like this in the question, right? That the array elements lie in the range this and this, then you can think of applying cyclic sort. And what the idea behind this is that whatever the input you are given, let's say this was this, right? I'll copy this, paste this over here, wait, paste this, yes. So what would be the, remember range is 1 to n, so what should be the ideal case? 1 2 3 4 up to n after sorting. So if I think of the ideal case applied in the array, then what should it look like? What should it look like? 1 2, and here it should be 3, here it should be 4, which is also there, and here it should be 5, but 5 is not present in the array. So I don't know what will come here, but let's say something comes up here, and then there should come 6. 6 is also not there, then I will add a question mark, and then there will be a 7 which is there in the array, then there will be 8 which is also in the array. Now there will be so so there are 2 repetitions that will occupy this. All the elements has been checked, and of course these 2 elements will be the repetition of 2 and 3, but either one of them will be there, but we don't know yet. So so what we need to do, just apply the cyclic sort algorithm, and whenever we find a condition wherein our ARR of I is not equal to ARR of ARR I minus 1, so which means that if my 1, considering I to be 0, if you look here, what is ARR of 0? This is I not equal to ARR of I, that means 1 minus 1. If my 1 is not equals to ARR of 0, which is 1, which is true here, so we don't need to do anything. We only do swapping if this condition is violated, that is ARR of I not equals to ARR of I minus 1. Then we swap ARR of I comma ARR of I minus 1 after swapping, and if this condition is not violated, then everything is fine. Then in the else part we move further. So this sorting algorithm works in O of n time. This is like linear time, and also we do not need to use any extra space apart from the vector itself that we will make, right? Yeah. Vector, it is asking to return the duplicates, all the duplicates. So I think I will need a set first, an ordered set, and then I'll need to use a vector so that I can return only unique keys, right? So let me just okay, so here is a catch in this question that only where I said that the repetition will be there, which was represented by these question marks. So whenever there is a repetition, let's say 2 is repeating, so it will repeat only once. That means 2 can only come twice in the sequence. Same for 3, it will not appear more than twice. Okay, so that was the catch. So we do not need to use any set, we can eliminate the usage of set because after sorting our array would look something like this. Let's say something like this, 1 2 3, and if the number is not there, and then anything can come here, right? Apart from its apart from its ideal position. So yeah, so what do we need to do is use sorting and then iterate over the sorted array and check if any element is not equal to its index plus 1. If it is not, then we need to store that array of I, which is the repeating element. If we were asked about the missing element, then we would have returned when we would have stored I, because I was missing, or similarly I plus 1 is missing according to the question. So let's code it up quickly. Size and I will take a while loop. After taking a while loop, I'll go from 1 to n, and I'm only showing you the cyclic sort approach. Like I said, if my nums of I not equals to nums of I minus 1, then I should swap what? Swap nums of I with nums of I minus 1, right? And after swapping, I'll just continue, or otherwise I'll just if the sequence is correct, I'll just move on. And after doing so, my array is sorted now. Array is sorted. That means any number which is present at the wrong position is our repeating number. So I'll make a vector which will be for my answer, and I'll iterate through the loop. I'll iterate through the vector int I equals to 0, I less than n, I plus plus, and if your nums of I not equal to I plus 1, then you should do answer dot push back nums of I. After doing so, you can return answer. Let's run this. Let's submit it up. So yeah, that was it for the video. Thanks for watching.